to do this than what I'm about to go over, but really after that topic. So to get started, we have to talk about the rational zero theorem. Now it's on page 377. But the rational zero theorem tells us that if we've got a polynomial, we know all the potential rational zeros, okay? If we're given a polynomial, we know all the rational zeros, and it's based off the constant and the leading coefficient term. So it's easiest really to do this with an example. And I'm going to steal one straight from the book, actually from your homework. I believe it was number 22 worked really well for this example. Where am I? There we go. So 22 on page 387. So now I'm gonna write this as a function. 2x cubed, it doesn't, it writes it as an equation, which is fine. But 2x cubed minus 5x squared minus 6x plus 4. So I'm going to think of this as my function. And the rational zero theorem actually looks at the constant term and the leading coefficient. So your leading coefficient is always the number for the leading term, right? The coefficient for the leading term. And the first thing we're going to do is actually break down each of these factors, okay? So 4 has factors of 4, 2, and 1, right? Those are all the numbers that are divisible into 4, okay? 2, it's just 2 and 1, right? Those are the two numbers that are divisible into 2. So those are its factors. Now, the way you find this actually, all the potential rational zeros, look, we know there's only 3, right? Rational zeros. All the potential rational zeros come from dividing the constant factors by each of the leading coefficient factors. And now the sign doesn't matter because actually you do a plus or minus on each one. So I want you to watch me do this real fast. I'm not going to do real fast, but watch me do this with an example. It's kind of the easiest way to understand it. So I've got now look, this is from my constant over here. In your book, I think they call it P. And then I think Q is the leading coefficient. So if I want to find all the potential rational zeros, first off, I'm going to put plus or minus in front of all of these. This is how I systematically do it, okay? I take the first P value and I divide it by both of the Q values. So 4 over 2, that's going to be my first one, 4 divided by 2. Then 4 divided by 1, okay? And then I go to the next, so I'm kind of done here, right? Now I go to the next P value, and I do 2 over 2, and then 2 over 1. So I divide it by each of the leading coefficients factors. So I'm done there. Then I go to 1, and I do the same thing, plus or minus 1/2, and then plus or minus 1. So 1 over 1. So now, look, I'm going to clean this up because, as you can tell, there's repetition. 4 divided by 2 is 2. It's there and it's there, right? 4 doesn't repeat. 1 repeats as well. So I'm going to clean this up and kind of write it as a set. So to write it as a set, we use the squiggly brackets. And I'm just going to start right here. So 4 divided by 2 is 1. So plus or minus 2. 4 divided by 1, that's just 4. 2 divided by 2 is 1. Now 2 divided by 1, that's 2. It's already in my group, right? So I don't have to repeat it. So I'm going to go to the 1/2, plus or minus 1/2. And then 1's already in my group because it was 2 divided by 2. So that's it. These are all of my potential rational zeros, okay? So I've got really 8 potential rational zeros. Right there. Okay, I've got 8 of them. Positive 2, negative 2, positive 4, negative 4, positive 1, negative 1, and then positive 1/2, negative 1/2. Okay, I have 8 potential rational zeros. Okay, so I'm going to give you one now, and I want you to try it. Let me steal one from the book. Actually, I'll just make one up. So same thing. I want you to list out the potential rational zeros here. Let's say I had g of x equals 3x to the fourth minus 2x squared plus 5. So I want you to find, so part A for a lot of these questions is going to say find all potential rational zeros. Now, if you don't know what the word rational is, rational just means any number you can write as an integer over an integer. So like 4 over 2 is rational. It winds up being 2. But 2 over 1 is rational. Irrational numbers, of course, like pi, square root of 2, imaginary numbers, they're all not rational. So these are the potential rational numbers. So try that. Find all potential rational zeros just based off this one example. I'll give you a minute, and then, of course, I'm going to go over it. Let's see if you can do that. Okay, so let's see here. So look, I'm going to think of the constant. I'm just calling them P and Q because your book does. I don't really use that notation, but I'll keep it consistent. So the constant here is 5. Well, the only factors of 5 are 5 and 1. 3, well, the only factors of 3 are 3 and 1, right? Because they're both prime numbers. So if I wanted to find the potential rationals, I'm going to start with a 5. I'm going to say plus or minus 5/3, plus or minus 5 over 1, right? Done there. Then I'm going to go to the 1/3, plus or minus 1/3, and then plus or minus 1, 1 over 1. So the actual, now nothing repeats here, so I would just rewrite it. 5/3, this is just 5, 1/3, and then this is just 1. Okay? You guys have any questions about that? I'm going to do this a lot in the lecture, like for part A of working these, but if you have a question about it, something doesn't make sense, please just ask to see where it's coming from. Okay, so now let's actually solve one. Let me rephrase this. I'm going to solve one of these by the book, okay? And by the book means this is how your book wants you to do it, but I want your brain to think, how in the world could I do this quicker, okay? There's no way I have to spend this much time and effort into a single problem, okay? So I'm going to go back to that first question, or the first one I gave you, that f of x equals 2x cubed minus 5x squared minus 6x plus 4. Now remember, for part A, the potential rationals. Now I'm just going to rewrite what I found on the other page. Okay, we already found this one. This was plus or minus 2, plus or minus 4, plus or minus 1, and plus or minus 1/2. Okay, so a few things before we get started. It turns out if we have irrational zeros, they always occur as a pair. Okay, so I'm going to kind of write this over here. This is important for other stuff that we're going to do. So if we have irrational zeros, like let's say, the like a plus bi, they'll always occur as conjugates. So a minus bi. The same thing is true with square roots. If it was like 1 plus the square root of 7, it's always going to have a pair of 1 minus the square root of 7. So it turns out irrationals, or like let's say 4i, negative 4i, okay? If we have irrational zeros, they're always going to occur as a pair. So when I see that this has a degree of 3, it tells me that at least one of these 8, right, potential zero rationals is an actual 0, okay? Because irrationals have to occur as a pair. So let's say we had a pair of irrational zeros, right? Pair of irrationals, well, there's only 3 total, right? We can only have 3 total. So since a pair of them are already irrational, that means at least one is actually rational, okay? I know that sounds goofy, but it's just how it is. So if you have an odd number or an odd degree, you have at least one rational 0. You have to, because all the irrationals occur as pairs. I'm going to put that down. Irrational zeros occur as pairs, okay? And we'll see it with this one, I believe. Okay, so here's how you do this by the book. So part B is going to say, hey, find all zeros. And unlike yesterday, or not yesterday, but unlike 3.3's lecture, there's no spoon feeding. You just got to find them now, okay? And it kind of just throws you in the deep end. I mean, not really. If you've done the homework, you're not thrown in the deep end here. But to work this the way the book wants you to, we've got to go through and check each one of these to find which one is a 0. So look, by the book, you're supposed to use the remainder theorem. And I'm going to do that, okay? Remember, the remainder theorem told us if we have a remainder, actually, I think it was the factor theorem, told us if we plug in a 0 and we get back a 0, it means that we're a 0. I said 0 3 different times in that same sentence. But if we plug one of these potentials into our function and we get back 0, it means that potential is actually a 0, okay? So let me show you what I'm talking about. I'm going to start plugging these away. I'm going to plug in f of 2, right? I'm going to start here. Plug in f of 2. And I get 2 times 2 cubed minus 5 times 2 squared minus 6 times 2 plus 4, right? 2 cubes 8 times 2, 16. 4, 2 squared is 4 times 5 is 20. Minus 12 plus 4. 16 minus 20 is 4. Negative 4, actually, right? That cancels with that positive 4. So we wind up with negative 12. Now, what matters here, though, is when I plugged in 2, I got back a non-zero. I didn't get back 0, okay? So this tells me that 2 is not a 0. 2 is not a 0. Okay? So now I'm going to plug negative 2 in. And I'm going to do the same thing. You can pop in your calculator if you want. 2 times negative 2 cubed minus 5 times negative 2 squared minus 6 times negative 2 plus 4. So negative 2 cubes, that's a negative 8, right? It keeps a sign. Times 2, that's negative 16. 4 times negative 5, that's minus 20. Plus 18, or plus 12, not 18. Plus 4. So we wind up with, now this 16 and this 16 cancel. So there's 16, there's negative 16. So you wind up with negative 20. Again, what matters is this isn't 0, right? So it tells me that, look, and I hate writing on this, but that 2 and negative 2 aren't zeros. We kind of marked them out. We plugged both of them in, not zeros into the function. Or they're not zeros of this function, I should say it that way. So let's plug in 4. So f of 4. I plug 4 in. I get 2 times 4 cubed minus 5 times, not 4, 2, but 4 squared minus 6 times 4 plus 4. 4 cubed, 64 times 2, that would be 128. 4 squared is 16 times 5, that's 80, I believe. So minus 80. Minus 24 plus 4. Let's see here. So negative 80 minus, so it's negative 104. Well, that's just 20. So negative 100. I believe this would be 28. Okay, you might want to pop in your calculator. All that really matters is it's not 0. So 4 isn't 0. Now I got to check -4. Running out of space here. So let's plug -4 in. 2 times -4 cubed minus 4 times -4 squared minus 6 times -4 plus 4, right? I ran out of room. This will be -4 cubed. Again, that's -64. So that's -128. This is still -80 because you square it negative, but then we're positive and then negative. Plus 24 plus 4. So f of -4 winds up being, this will be 28. So like -180, right? Again, all that matters is that it's not 0. So I can mark out 4. Jesus, where is the 0? So now we got to go to 1. 1 will be easier to plug in, right? I plug 1 in. Look, I'm going to kind of do this one in my head. 1, it just becomes the coefficients, right? So this turns into 2. So 2 minus 5, that's -3. Minus 6, that's -9. Plus 4, that's a -5. Okay, so not 0. Let's plug in -1. -1, this would become negative, so it would be -2 here. This would still be positive, so -5. This would become a +6 because you multiply it by a negative, and a +4. -7 plus 10, so that's going to be 3. Dang. Still not a 0. So now let's do 1/2. 1/2. I'm going to write underneath it because I know I'm going to run out of room here. 2 times 1/2 cubed minus 5 times 1/2 squared minus 6 times 1/2 plus 4. 1/2 cubed is 1/8. It's 1/2 times 1/2 times 1/2. You can use a calculator, but 1/2 times 2 would be 1/4. So this term winds up being 1/4. 1/2 squared would be 1/4 times the -5, so it's -5/4. This would be, well, 3, right? -3. This would be plus 4. Well, 1 minus, this would be -4/4. -3, that's negative. Hey, here we go. This is -1 minus 3 plus 4. This is 0. We found it. We found it. Boom, shakalaka. It took us this whole page, but we found that 1/2 is a 0. Okay? We knew the potentials. We started plugging in. And finally, we found that 1/2 was a 0. Now look, we know what to do from here. Because what we do from here is what we did at the end of section 3.3, I believe. It might have been 3.2. So I'm going to go back and write this. I'm going to say f of x equals 2x cubed minus 5x squared minus 6x plus 4. And we know x equals 1/2 is a 0. And we have to find the other zeros now. Okay, this is no big deal. We did this a few lectures ago. If we know that 1/2 is a 0, we just have to divide it out, right? 2, -5, -6, and 4. So bring down the 2. 2 times 1/2 is 1, right? Add those vertically, -4. -4 times 1/2, that's just -2. Add that vertically, we get -8 times 1/2 would be -4. We wind up with 0. Now we knew that this was 0 because the remainder theorem, right? When we plugged 1/2 into the function, we got back 0, and it tells us the remainder. But what's important that we went over last time is that if 1/2 was the 0, remember x minus 1/2 was the factor, and your quotient is actually what's left over. So 2x squared minus 4x minus 8. Great. Okay. Now look, we're just trying to find zeros. We've got it down into a quadratic. We can find the last two zeros. You can try to factor this if you want. I'm not worried about it at this point. At this point, I know I can solve this quadratic, and it will tell me the last two zeros, right? I know one of them already. I got to find the last two. And if I'm going to solve this one, I'm going to divide everything by 2 because it's a quadratic. Or because they're all divisible by 2, not because it's quadratic. This doesn't factor. It kind of looks like it does, but it doesn't. -4, that's either -2 times 2, which adds up to 0, or like 4 times 1 or -1 or -4 times 1. None of those add up to -2. I'm going to have to use the quadratic formula on this one. So I'm going to go over here and just do the quadratic. So x equals -b plus or minus the square root b squared minus 4 times a times c all over 2 times a. Remember, I like finding out what's underneath the radical first, so I'm going to kind of do that up here. -2 squared is a +4. -4 times 1 times -4, that's a +16. So we wind up with 20 underneath the radical. All over 2. The 20 can be broken down into what? 10 times 2, 5 times 2. So I could take a 2 out. I got a 5 left over. And notice all these 3 are divisible by 2. So you wind up with 2 divided by 2 is 1, plus or minus 2 divided by 2 is 1, so square root of 5. So those are the last two zeros. So remember, the question was find all the zeros. The first one we found was 1/2. The other two are right there. Why? 1 plus the square root of 5, 1 minus the square root of 5. And I know I can't have another 0, right? 3 of them. And I found all 3. Kind of neat. Whew, that was a lot of work, right? And we're going to do, like, for the next hour, we're going to do this over and over again until it gets boring. But I'm going to pause it here. And I know it's hard to really kind of communicate on Zoom because if you want to say something, but I want you, I'm gonna test something out in chat. Hold on. Can you? No. Okay. So in chat, if you want to tell me what you think is a quicker way to do this, and I promise you there's quicker ways, just like type it in chat for me, or you can hit me. You just type me in chat. That sounds goofy. Just type me, and I'll call on you, because I want to hear what you have to say. If you don't want to talk, that's fine. But I want to hear what a quicker way you think we could do this, other than wasting 2 pages of paper on it, right? Holy hell, y'all! We did that. We found the potentials. We plugged them all in, and then we divided out. Now I'm going to tell you, this is going to take as long as it takes. It's this page really that we could shorten. How do you think we could shorten our efforts here and become more efficient? Hell, you can just give me a thumbs up in the emoji thing, and I'll take that. If anyone wants to give their thumbs up. Oh, guys, I don't want to do this over and over again. I don't want to plug in every single potential rational over and over again. Can you guys think of a way we could not have to do this? Oh, now we still need to know it. We still need to know the potential rationals. They're going to help us out. But is there a way we could get away with not doing it over and over again? Okay, oh man, I'm going to have to do it over and over again. Okay, that's fine. That's fine. Let's do one more, and maybe you'll kind of see it. Let's say, this is actually kind of an easier one, okay? Let's say we got f of x equals x cubed plus 7x squared plus 11x minus 3. Okay, so for part A, I still want to know the potential rationals. Okay, This one won't be bad because look, we're dealing with a 1 here, right? So the P is going to be -3. Look, it doesn't matter that it's positive or negative because all of them become plus or minus anyway. The Q is just 1. So the potential rationals are very kind of limited here. It's only 3 and 1. So it's just going to be plus or minus 3 over 1, plus or minus 1 over 1. So there's only 4, right? I mean, if you want to write it without fractions, plus or minus 3, plus or minus 1. Okay, this one will be a little easier to find. So let's see. We've got f of x. I'm going to plug in. Actually, that's all the potential rationals. We're done there. So part B is going to say find all zeros. Okay, so I'm going to start on this. I'm going to start on 3 now, and I get 3 cubed plus 7 times 3 squared plus 11 times 3 minus 2, right? 3 cubes 27. 3 squared is 9 times 7 is at 63 plus 33. Look, I'm not going to worry about the math here. This is just not 0, right? There's no way this is 0. Big number, big number, big number, minus small number, not 0. Okay, so let's plug in -3. So -3 cubed plus 7 times -3 squared plus 11 times -3 minus 3. -3 cubed, that's going to be -27, right? Because it's cubed, it keeps a sign. This will be a positive 9 times 7. This is still 63. This will be -33 minus 3. This has potential. So -27 minus 33, that's -60 minus 3. Boom, shakalaka. We found it. Check me, make sure I'm right on this one. I believe that adds up to 0. So that tells me this -3 is a 0. Okay, -3 is a 0. Now we've got to find the other 2 zeros, right? To find the other 2 zeros, I'm going to divide this -3 out, and then it's going to leave me with a quadratic. Remember, quadratics are safety counts, right? Once we get this thing into a quadratic, we're fine. We know how to solve quadratics. We can do the formula, we can do factoring, we do all kinds of fun stuff. So I'm going to do that on this side of the paper. Actually, I'm going to do the division down here. So -3. The coefficients, right, are 1, 7, 11, and -3. So bring down the 1, -3. Add that, I get 4, -12. Add that, I get a -1. Multiply that, I get a +3. Boom, right? We knew that was going to be 0, though, because we did our math correctly, hopefully. And we knew that when we plugged in -3, we got back 0. Okay? But here's our coefficient, or here's our coefficients for that quadratic. So really what we have now is f of x equals, look, -3 was the 0. So x plus 3 is the factor. And then this is our little quadratic, x squared plus 4x minus 1, right? Our last 2 zeros are hidden in this quadratic. Are there any questions about this? I'm going to pause right here. Are there any questions about what we're doing other than, okay, I just need to see a few more examples. I don't have it really hemmed up yet, but okay. I'm going to assume we all get it, or we all just need to see a few more examples. So let's toss this into, actually, if you had the calculator, if you've got the quadratic solver in your calculator, you can just do it with this one. It's nice. If you don't have that, you can talk to Miss Althea on campus. She's the tutoring. She works in the tutoring center. Email her. I can get you that information, actually. I know she has it where you can load it in your calculator. But let's just do the old school quadratic. So -b plus or minus the square root b squared minus 4 times c times a times c, 4 times c times a squared, all over 2 times a, 4 times a times c. I got those backwards, guys, but that's fine because it's multiplication. So underneath the radical, we would have 16 plus 4. Hey, we got 20 again. That's crazy. Interesting. So we know that's 5 times 2 times 2, so I can take a 2 out. So we get x equals, now it's negative 4 out front, plus or minus 2 square root of 5 all over 2. Now each of these are divisible by 2 again. So we get negative 1 plus or minus this, oh, not negative 1, negative 2, right? 4 divided by 2 is negative 2, plus or minus the square root of 5. So our zeros are negative 3. We found that one really the hard way, right? And then the last two we found from the quadratic, negative 2 plus the square root of 5 and negative 2 minus the square root of 5. Okay. Questions, comments, concerns? You know what, just for fun, I want to try to graph this. Now, if I'm going to graph this, I need decimal approximations of these two. So I'm going to put those in my calculator just to do a decimal approximation for the graph. So I'm going to take my calculator out. Let's see here. Negative 2 plus the square root of 5. That's 2 so this is the decimal approximation group. That's 0.236. Now negative 2 minus the square root of 5 would be negative 4.236. So if I was going to approximate them as decimals, that's what the zeros would be. Okay, so let's graph this. What did I say again? Oh, wait, it's down here. Negative 3, so we'd go to the left to negative 3. Or negative 4, right? 1, 2, 3, 4, 5. Two, 3. And let's see, negative 3. 1, 2, 3. Negative 4.2, about right there. And then positive 0.23, so about right here. Okay. Now we know, remember, the y-intercept, when you're written in this form, just comes from that constant negative 3 right there. The end behavior is odd. It's just like the ones we did in the other class, right? The end behavior is odd, but the leading coefficient is positive. So I know that this is going to go like this to the right, up and to the right, and it's going to go down and to the left. And it does something like this. Now, it's a lot more dramatic than this, but it does something like this, okay? Something like that. So this is a rough sketch, just a rough sketch of what's going on, okay? Questions? Okay, so if I gave you this sketch to begin with, and I asked you which one of our potential zeros is the actual zero, well, let's see. Imagine I gave you this sketch first, and I said, hey, here's our potential rational zeros. Which one of these are actual zeros? Well, this graph doesn't go through positive 3. That's like out here somewhere, right? Doesn't go through positive 3. I know that's not a zero. Negative 3, hey, this graph goes through negative 3. That's got to be my zero. It's got to be one of them. Same thing with positive 1 and negative 1. This graph doesn't go through positive 1 or negative 1. So the only rational zero is going to be positive 3. So if we had some form of technology that could graph these functions, then we could probably narrow down the potential rational zero. And oh, we do. It's that TI-80 whatever calculator you bought. Now, I let my son borrow one today because he had to take the PSATs. So I don't have mine on me, but I'm going to go step by step because I know some of you have never used this calculator. I'm going to go step by step on how to graph in this calculator, okay? So let's do that with another example, and we'll see how much time we shave off. We don't have to plug in all that crap, okay? If we do this. So let's do another example here. Okay. Hold on, give me a second, guys. I just want to find a good example, not a bad one. Okay, hold on. Okay, I'm just going to do an odd. That's fine. This is number 19. See if you get the same thing. Oh, actually, no, let's do 42. 42. That way it's an even. 42 says, now it's got an equation. It's okay. Look, if you see an equation, it's on page 387. I want you to automatically think of it like a function. Okay? 3x cubed minus 8x squared minus 8x plus 8. Okay? Now for part A, we're going to list possible rational zeros. Possible rational zeros. So I know, the constant, that's 8, 4, 2, and 1, right? Those are all factors of 8. The 3, it's just 3 and 1. So if I want to list these out, I'm going to start with the 8, right? And the way I do it is I say 8 over 3, 8 over 1, 8's done. 4 over 3, 4 over 1, 4's done. 2 over 3, 2 over 1, 2's done. And then 1 over 3 and 1 over 1. Ooh, it's a lot of potential rational zeros. So I've got 8 thirds, 8, 4 thirds, 4, 2 thirds, 2. Holy cow, yeah, all these, none of these were used twice. That's 1, 2, 3, 4, 5, 6, 7, 8, 16. I've got 16 potential rational zeros. That's crazy. Okay. I am not going to plug each one of these into here before I find out which one is a zero. I'm going to graph this, and then hopefully from the graph, I can at least narrow it down. Sometimes the graph can show it. Look, if it's +4 or -4, it'll be kind of easy to see on the graph. Okay. So I'm going to show you how to do that. So part B is just going to say find all zeros. But the very first thing I'm going to do is graph it. So here's how we do this. Now I've got my phone. I've got my phone calculator, which I kind of use a free software. I don't know if it's the same. I'll see. Hold on. Ugh, yeah, it's not the best. Zooms. It's not the best, but it kind of gives you the right buttons. Okay, so here's my phone. Here's my janky phone that has been broke a few times. What you're going to do to graph in that calculator, which is very similar, the buttons are very similar. The very first thing you're going to go to is y equals. It's that very top left button, okay? And click on it. Boop. And you'll notice now, actually, your first y equals will say y1. That very top one. And then we're going to plug this into that calculator. Now, here's the way you do this. First, you're going to write 3, right? You're going to put this in. To get the x value, you need to hit, on yours, it's x, comma, t, comma, theta, comma, n. It's the button right under mode. Okay, that button right under mode should pop up x. And then to cube it, you hit the caret key, which is right under clear. And then hit 3. Now make sure you're out of the exponent. So hit to the right one and it'll come back down. And you should have 3x cubed in your calculator. okay? The
Wait,
minus,
can you repeat how to put the degree in again? Sorry.
the caret button right here.
Okay.
Yep. And then when you do that, Chastity, does it automatically make an exponent?
Yes, I got 3x cubes now.
Yep. And then make sure you hit to the right after that so it gets out of the exponent. Your cursor's out of the exponent.
Okay.
Okay. And then hit the minus button, not the negative button. This button right here is meant for like -4, -5. If we're actually doing subtraction, you want to hit this minus button under the multiplication. Okay. So minus, and then we're going to do 8.
Oh, cool.
And then we're going to bring up the x again. So remember that's x comma t comma theta comma n. And then we're going to raise it to the second power.
Got it.
And then go to the right one.
Okay.
And then minus the actual minus button. Now we just have to put in 8x, right? And then do not forget the plus 8. Okay, so plus. Yeah. Now, once you have that in, it should look something like that. Yours will look a little different because it's not a hit the graph button. At the very top right, you're going to hit it. There's a graph key. And yours is going to look something. Actually, yours is going to be more zoomed in because it only goes from like -10 to 10. See if I can get it. It'll look something like that. And yours actually has digits, right? For the ones.
Mine doesn't have any. Well, I have it has little marks, yeah.
Yeah. But here's the thing. Here's what we're gonna do. We're gonna, from this graph, like your graph, we're gonna narrow some of these and say, look, there's no way some of these are the correct answer. Okay. So like if you look at your graph, like, and if you're watching just on mine, I can tell that like 8 and -8, they're not zeros. They don't cross through the x-axis. Do you guys see that?
Yes.
Okay, look, 8's over here, -8's over here. It's not crossing through. So I'm going to make a little X underneath there. I know that it's not -8 and +8. Okay. Now with yours, it's probably a little easier to see because you have the little digits. I don't know if I zoom in more. I don't know how to zoom in on this. This is what you get, what you pay for sometimes on this stuff.
Isn't there a way to zoom in on it?
There is a way to zoom in. I'm talking about on mine though, on this free one. Yeah, you can hit zoom and then like the zoom button somewhere on your calculator. Anyway, but let's just kind of narrow it down. Okay, does it go through 4 or +4?
No, I don't think so.
No, I don't think so either. Does it go through 2 or +2?
No.
Is it a maybe?
No, I don't think so.
Okay. What about 1 or -1?
It looks like it goes through -1.
Okay, well, let's check it. If you think it's -1, let's check it. So I'm going to plug in -1 into here, right? So maybe -1. Maybe -1. So we get f of -1 equals, now this will be -1 cubed, that's -1, right? So we get a -3 for the first term. -1 squared, that's positive, so this would be -8. -1 here, this would be a +8, and then a +8. So for -1, we get back +5. So that's not going to work. Now,
okay, how? It just looks like it's
it just looks like it. It's probably a fraction. So it's probably not one. Now, what about that was -1? What about +1?
No.
Okay.
It looks like a fraction there as well.
Gotcha. Okay, now 8/3, that's like what? 3.66. Okay. If you do it, or no, it's not 3.66. It's 2.66.
I was gonna say 2 point.
2.66. So does it look like it goes through +2.6 or -2.6?
I
don't think so, because look.
I don't either. It looks more like 3 to me.
Yeah, no. Not 8/3. Right. Which one do you think it is?
3? Do we don't even have a 3 on there?
Nope. So that's not gonna be one of them. Let's say, what about -4/3?
I was thinking positive, maybe. Negative 4/3. That looks like it. Yes, actually it does.
Yeah, it kind of does. Okay, so let's do negative 4/3.
All right. So
Okay, this is gonna be a nightmare by hand. So I'm gonna go in my calculator and put this in my calculator. So guys, if you want to do this with the calculator, if you're really not familiar with this TI-80 calculator, what's nice about it is you can put this whole thing in. So negative 4/3, I'm just gonna replace next to negative 4/3, right? So I'm gonna say 3 parentheses. Now the negative 4/3, to get that, I am gonna use that negative button at the bottom, okay? 4 divided by 3. And then I'm going to square it. No, cube it. Minus 8 times negative 4/3 squared. Minus 8 times negative 4/3 plus 8. Ah, we were close. It's not 0 though. Okay, I plugged all this in and it's not 0. You get back negative 2.6 repeating.
what in the world is it then?
That's okay. So that was, well, it's definitely not 4/3.
It's gonna be 2/3.
It's gotta be 2/3, right? It's gotta be 2/3. Let's try.
It is. That's what it is.
So if we did 2/3, so I'm gonna do second enter. Second answer. It doesn't let me do all that. Okay. So let's try 2/3. I'm just gonna do it by hand because I'm not used to that calculator on the phone. You do not have to do this by hand. Actually, there's a much quicker way to do this. Man, it's like of all days that my kid has to take that PSAT. Okay, let's see here. So 2/3 cubed, that's going to be, you have to cube both the top and bottom. So that's 8/27. Minus, I know. And you've got the calculator. You don't have to do this. This is me doing it. Minus 16/8 plus 8. Now this is going to be 3 and 27 cancel out. That's 9. So this winds up being 8/9. 8 times 4 is 32/9. Minus 16/3 plus 8. Let's see here. 8 minus 16 or 8 minus 32 is
24. Negative 24.
Minus 16/3 plus 8. Now you got to get a common denominator, so I'm going to multiply these top two. So this will be minus 24/9 minus 48/9 plus 8. Ugh.
I know.
24 plus 48, 72. Oh, heck yeah, there it is. Negative 72/9 plus 8, that's 0. Now, guys, just put that in the calculator. That's way too much work, right?
Yeah.
So it winds, but we found our 0. It's 2/3. The crowd goes wild. Yay. Okay. So let's clear that out. So we know, look, we didn't have to plug in all of these potential rational zeros. This is kind of an extreme example, okay? We did not have to plug in all those zeros. We could, just from looking at the graph, we can start to say, hey, look, it doesn't go through 8 or 4, 2 or 1. Those can go away. It doesn't go through the plus or minus. So it's got to be 2/3 or 1/3, whatever. We don't have to test as many, okay? And that's what's nice. But let me rewrite this one. Knowing we have finally found one of the zeros. I'll do an easy one next, guys. It's more like the ones we're going to see, okay? But we know now we found x equals 2/3 is a 0, right? So I'm going to divide it out. What number? 42? Yeah. That's crazy. Okay, so bring the 3 down. 3 times 2/3, that's 2, because it would be 6 divided by 3. So that's 2. Add that vertically, we get -6. -6 times 2/3, that's -12 divided by 3. That's -4. Add that vertically. -12 times 2/3, well, -12 times 2 is -24. Divided by 3 is -8. So we do wind up with 0. We knew that was going to happen. But let's look and see what we have. We actually have x minus 2/3 times 3x squared minus 6x minus 12. We can use a quadratic calculator to find the last two. I mean, we'll probably just have to use a quadratic formula again. So 3x squared minus 6x minus 12 equals 0. Divide everything by 3. X squared minus 2x minus 4. Did we solve this one already? I feel like we did.
Feels like it. I don't think so, though.
Oh, we did. This was the same quadratic we had earlier. Isn't that crazy? So
How
look,
did we end up with the same one? That's crazy.
I don't. Your book's being very unoriginal because these are the ones I stole from the book, or I'm being very unoriginal. That's what it is. So I'm going to be lazy and say, hey, we already found this. We did the quadratic earlier, and we found out that the last two solutions are 1 plus or minus the square root of 5. So there's our three solutions: 2/3, 1 plus the square root of 5, and 1 minus the square root of 5. Okay?
That's cool.
It is. You're right. It is cool. It's super cool. Now, look, I'm going to give you this. This one's going to be a little easier. Okay? I'm going to tell you that up front. You might not think that, but I'll tell you, this one's going to be easy to see the 0. So I want you to graph it again. I'm not going to show you how to do it. I want you to do it by hand. I want you to graph it again, and then I want you to see if you can see the 0 and then divide it out. This is number, I see that. Oh, yeah, no. This is number 20. And again, I'm going to think of it as f of x. X cubed minus 15x squared plus 17x minus 13. X cubed, 20. X cubed minus, oh, you know what? I lied, guys. I don't know why I wrote 15x. It's 5x, okay? 5x right there. X cubed minus 5. I'm going to have to write this all over again. It's going to bother me. X cubed minus 5x squared plus 17x minus 13. Now, the first thing I want you to do is the same part A. List all potential rational zeros. And then for part B, I want you to find all the zeros. So try this one, okay? Try this. So I'm going to give you a little bit. It's okay if you don't get it correct. It's okay if you get lost. The reason for this is to kind of see where you're at, okay? Kind of see what you know and don't know. So try that. I'm going to give you a minute. And Sherry, if you want to put the link in chat for that calculator, I'd appreciate it. That'd be see what's up with it. Okay, had to go get some water. Okay, I'm going to start this one. Let's see. The rational zeros, potential rationals are pretty easy here because they're both prime, right? So we've got 13 and 1 and then just 1. So that means we've got plus or minus 13 or plus or minus 1. Now, when you graphed this, was it very clear which one of those was a 0?
Yes.
Which one was it?
1.
Positive 1?
1 to 0. Yes, sir.
Okay. So I'm going to divide that out. I'm going to trust Chastity.
Yeah,
and
I can see it.
Okay, I'm going to divide it out. And I wind up with, so 1, negative 5.
13.
17.
Yep. I was right.
4, 13, positive 30. Oh, yeah, you're right. Right, winds up being a 0. So we get f of x equals. Now we know that's x minus 1, right? Because that 1 was a 0. And it's x squared minus 4x plus 13. This doesn't factor. 13 is 13 times 1. I'm going to have to use the quadratic here. So we'd have, for the other two zeros, set that equal to 0. So you get x equals negative b plus or minus the square root b squared minus 4 times a times c. Oh, over 2 times c. Underneath the radical, I'm going to put it way up here. I get 16 minus 4 times 13, which is like 52. Yeah, it's a deck of cards, right? And then 16 minus 52 is what? 30 something.
That's negative.
Negative 36.
Oh, yeah.
So x equals 4 plus or minus the square root of negative 36. All over 2.
2 times 4.
So 4 plus or minus 6i, right? All over 2. Can't add these together. We got real and imaginary, right? But we can divide both of them by 2. So 2 plus or minus 3i. There's our last two zeros. So the zeros wound up being 1, 2 plus 3i, and 2 minus 3i. Okay? 1, because we found that from the graph, right? And then I'm gonna, so I haven't graphed this, but I know if you're looking at that graph, it's only crossing the x-axis one time, right? And notice how these occurred as pairs: 2 plus 3i, 2 minus 3i. And and I haven't mentioned it with the other ones before, but notice like the previous one, 1 plus the square root of 5, 1 minus the square root of 5. They're going to occur in conjugate pairs that way, if they're not rational, like 1 or 2 or 13 or 2/3.
Oh, yeah, okay.
Okay.
I get it.
Questions. I've only got you for like 15 more minutes. We've got so much to go. We don't have a ton to go over, but there's a lot of different examples, and I can't hit every single one. So I am going to hit one that is kind of common to pop up, and it's kind of interesting actually. But when you get to the homework, you're going to see some that might not look like examples we've covered, but I promise you, if you can do the ones we've covered, you've got the tools to do all of them, okay? This is number 24. And again, I'm going to think of this as f of x equals x to the 4th minus 2x squared minus 16x minus 15. Automatically, I'm writing it as a function. So part A, just because we've been doing it already, let's do the potentials again. And again, it will be kind of nice. So 15 is 15, 5, 3, and 1, right? Those are all divisible into 15. This coefficient is just 1, so it just makes it the factors of 15. So 15 plus or minus 15, plus or minus 5, plus or minus 3, and plus or minus 1. Now, what's different about this one is it has a degree of 4. we're going to have 4 zeros, okay? And because we have 4 zeros, they might all be imaginary. So it might not cross the x-axis at all, right? We could have a pair of imaginary and another pair of imaginary.
Can't we just go ahead and graph it and see?
Yeah, and you won't be able to see it at all. You might have 2 pairs of irrational numbers. And I'm going to tell you, the book and on the test is not going to do that to you, okay? It's not that mean. Dr. Blitzer is not that mean. And I'm not that mean when it comes to the test. You'll be able to find some zeros from these potentials, okay? So I need you to graph this because I need you to tell me on that graph where you think the potential zeros are. So find. So graph that. And if you want to just put it in the chat, once you see on the graph where you think the potentials are, it would help me out a lot.
Why did I think you said this one wasn't going to hit the zeros or?
It might not. We don't know.
Well, I see some.
Yeah, you should be able to see some. Can you see where they cross? Are there some that cross kind of in a nice way?
I've got -1 and 3, it looks like.
Okay, look. To really solidify this before we actually do anything, if you hit second, I think it's second graph, it should bring up a table. Hold on.
Say that again. I'm sorry.
Yeah. So if you hit the second button.
Oh, yes, gotcha.
And then graph, it'll bring up a table, right?
Table. Yep.
And if it's a 0, look, these are x values, right? -1, if it's a 0, the y value is going to be 0. Same thing with +3. Now you might have to scroll up or down.
3 is a 0.
3 is a 0. What about -1?
Let me go back to -1.
You got to, if you scroll up, I think.
Yes, -1 is a 0.
Perfect. We know these are zeros based off the table and off the graph.
Cool.
Now what's different though is, look, we're going to have to divide these out one at a time to get to the quadratic. That's what's different because it's a 4th degree and not a 3rd degree.
Oh.
It doesn't matter which one you start with. I'm going to just start with the -1. So I'm going to divide -1. And I get 1, -2. Oh, we have missing zeros, don't we? We don't have a cube term. So I need a 0 for the cubes. This is the x to the 4th term.
Ooh, I almost left that out.
Added to -2, -16, -15. Okay, so bring this down. We get 1, -1, +1, -1, +1, -15, +15, 0. Okay. So what we have now, though, I know I kind of zoomed through that. You can catch up. But what we have now actually is x plus 1, right? That's the 0. We go down 1 degree, right? Now we have a cube term, or cubed polynomial. X cubed minus x squared minus x minus 15. Okay? Now here's the critical point. We know this 3 is another 0. We're going to pull this 3 out of the 3rd degree polynomial. We're not going to go back to the beginning. Okay. We already pulled the -1 out. So we're going to take the 3 out of this 3rd degree. So I'm going to do the same thing, but with this 3rd degree polynomial. So it's these coefficients right here. So 1, -1, -1, -15. Bring the 1 down, 3. Add vertically 2, 6. +5, 15, 0. Great. So now what we have, we already brought out the +1, or really -1, right? -1, so x plus 1 is the factor. Now if 3 is the 0, it's x minus 3. But what we have left over is our safety couch. We have x squared plus 2x plus 5. We've got a quadratic. We can solve the last two now because we have a quadratic formula, okay?
Mhm.
So I'm going to do that. So x squared plus 2x plus 5 equals 0. X equals negative b plus or minus all squared, blah, 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 minus 4a b all over 2a. Underneath the radical, we wind up with 4 minus 20. So do you wind up with a negative here? Yeah. You wind up with negative 16. Negative 2 plus or minus 4i over 2. So that means you've got, these are all divisible by 2 again. So negative 1 plus or minus 2i. So our zeros, now don't forget the negative 1 and the 3. And the negative 1 plus 2i and negative 1 minus 2i. Boom. So it was a little different because we had to factor out these one at a time, okay? We had to factor these out one at a time.
It wouldn't have mattered which one we started with.
No, man, we would have wound up, actually, if you would have started with the 3 first and then negative 1, you would have still wound up right here.
Right there. Okay.
Yep. You still would have wound up with the x squared plus 2x plus 5.
Sweet.
Okay. So for homework, now this is from 3.4. Page 386 starts there. 1 through 1 through 23. Now look, for these later numbers, it talks about Rene Descartes' rule of signs. You do not have to know that, okay? It's something that for some reason this author likes. And I'll tell you, Rene Descartes is a very interesting person, and he is definitely worth Googling and looking at his Wikipedia. But you do not have to worry about his rule of signs. So I just want you to solve the zeros for this last section, 39 through 51. Just one, yeah, this is it. That's all the homework. So 39 through 51, it gives you like a long example, you know, like, oh, use the rule of signs, blah, blah, blah. And no, don't worry about that. Just find the zeros. You can find them with how we've learned how to find them in the lecture. Okay.